Alright, welcome back for the final example for today. This one's going to be a little bit trickier. What if I want to solve the equation 2 times the secant of theta plus 3 equals -7? Alright, so this is actually going to require us to have some familiarity with the secant graph, which isn't quite like the other ones that we've been working with. It's not one of the traditional graphs. So let's see, we'll work in degrees this time. So 90, 180, 270, and 360. And secant is a reciprocal function, and it's actually the reciprocal of cosine theta. So secant is going to have some undefined values whenever cosine of theta is 0. So cosine, recall from the previous example, starts up at 1 and then drops down to 90, down to -1 at 180, back up to 0 for 270, and then back up to 1 at 360. So if cosine occurs at those points, alright, I'm just going to plot those just to help us get the reciprocal function, because I don't expect us to have this memorized just yet as to what the secant graph looks like. Secant is going to be undefined whenever cosine is 0. So at 90 degrees there's going to be a vertical asymptote, and at 270 degrees there's going to be a vertical asymptote. Now if I think about the cosine graph at the other values, being a reciprocal, what is the reciprocal of 1? Well, that's also 1. And what's the reciprocal of -1? Well, 1 over -1 is also -1, so the graphs will coincide there, and the reciprocal of 1 once again will be 1. And now for the values in between, if you imagine cosine being at 1/2, is actually at 60 degrees, when I do 1 divided by 1/2, that's actually going to give me 2 way up here. And I'll actually have a graph that kind of looks like this with a vertical asymptote. And down here, when cosine is regularly going to be -1/2, which I believe occurs at, what's that going to be? 60 plus 90, 150 degrees, I think. We'll end up with a value at -2, the reciprocal. So we're actually going to have a graph of secant look something like this. And you can reference your tables that you had made earlier, the graphs of all the different trig functions that we had done earlier, just to use as a reference sheet for our homework. It would definitely be a good idea just to have a general idea of what these graphs look like, but they can be reconstructed with a little bit of thought and a little bit of work when relating them back to, sine or cosine. But I do want to point out that secant does in fact have a period between 0 and 360. Notice that it starts repeating this part again, which is the same as this part over here, and it does repeat infinitely. So as far as the domain is, it's from -infinity to infinity, except skipping the spots at 90 degrees and 270, and any of their coterminal angles. It would be undefined. So it's got a bunch of holes in the domain. And as far as the range goes, it actually doesn't exist between -1 and 1. It does include the point 1. So it would be all points from 1 through infinity, and -1 through -infinity, but nothing in between. So let's actually look at the original problem. This graph is just for assistance. So if I want to solve for secant, what I'm going to try to do is get the trig function by itself. So imagine this was x, and imagine 2x plus 3 equals -7. We'd want to be moving the 3 and the 2. So let's do that. Subtract 3 from both sides, and I'll have 2 secant theta equals -10. And then divide both sides by the 2 to get rid of the 2. And I'll have secant theta equals -5. Alright, so I'm expecting secant to be negative. When is secant negative? Well, secant's actually going to be negative the same time cosine's negative. And so I'm expecting my answers to be occurring in the second and third quadrants. So once again, I'll actually have to consider the reference angle first. So I'm gonna be looking for the positive 5 version for starters, and then I'll be able to find the reference angle from there. So we'll be looking at that. And I do just want to point out that -5 is within the domain, or sorry, the range of secant, right? Because it does go all the way down to -infinity, and -5 is in fact less than the -1. So that is a legitimate solution. It's not going to be an undefined answer, or a no answer sort of problem. So in order to solve this, to get theta by itself, I'm just going to rewrite this step for our later understanding. I would take the secant inverse of both sides. And I will end up with theta. Oh, actually, I wanted to do it a +5 once again. So this will be our alpha. Our reference angle will be an approximation of secant inverse of 5. And I actually don't have a calculator with me at the moment, but that will give us a decimal approximation of our angle alpha. Alright, so those of you will have to use a calculator tomorrow to fill that in. To find secant inverse, actually, that's an interesting point right there. We should take a moment. I'll add one more step. So alpha is actually going to be the same as the cosine inverse, because I guess you guys might not know how to plug that in the calculator. And cosine is the reciprocal of secant, so I would do the cosine inverse of 1/5 on the calculator in order to figure that out. And that would be my alpha angle. Right, so that's going to be some value there. And what I'll be able to do with alpha, alright, so that's going to be when cosine is 1/5, that's actually going to exist somewhere over here as my reference angle alpha. So if I want to figure out when secant is going to equal that point, well, that's actually a little bit tricky, because this one isn't going to be bouncing around the 180 degrees, right? If I add and subtract alpha, actually, oh no, okay, alpha is this full distance here, I'm sorry. Right, so whatever decimal we get should be less than 90, and if I add that or subtract it from 180, that should give me my other two values. Alright, my actual thetas. So theta, my first theta, will equal 180 minus alpha. And I'm just going to leave it as alpha for now, but you guys at home or at school can hopefully use your calculators in order to figure that out. And theta on the other side, and actually these would be approximations, whatever your alpha ends up giving you from your calculator, 180 plus alpha. And these would be the particular solutions of when secant happens to be -5. Alright? These would be the ones that occur within a typical period of our function. Now, if I want to find all possible solutions, I would then take whatever my answers are and find their coterminal angles. So theta would then be the 180 minus alpha, whatever that number is, and I would add 360 n, right? Just repeated cycles around the circle, keep landing 360 degrees away in either direction, and I'll find the other solutions for that point. And this theta would be 180 plus alpha plus 360 n, right? And this is for n equaling any integer, like so. So these would represent all possible solutions for the original problem. Alright, so I do highly recommend that you at least reference your graphs for tonight's homework, just to be able to better understand when and where your points are, and it'll be a good idea. Just it helps with the reference angles. It helps figuring out, is -5 even within the range of this, and different things like that. So your graphs will very much help you out. And then also, it's not a bad idea to recognize where your quadrants are broken up within your graphs, and that will help you answer these questions. Alright, so absolutely use these videos as a tool when working on your classwork and on your homework. Pause them at any time, and hopefully that will be sufficient to answer your questions. And as always, feel free to email me, and I'll hopefully be able to answer some of your questions as well. And I look forward to seeing you soon. Alright, thanks.